So it's my pleasure to welcome this wonderful group of panelists to my left here. Just to give you some background, the point of this panel is going to be to have an accessible introduction to some of the big picture philosophical questions across scientific disciplines. So we often go to AI talks and they're often highly technical. So the point is that we're trying to see where different scientists and researchers agree and where they disagree when it comes to kind of the big philosophical issues. So Adina, if you don't mind starting off introductions and we can make our way down the line.
Yeah, sure. Hi, I'm Adina Williams. I'm currently a researcher in the Fundamental AI Research Group at Meta. I'm based in New York. I have a team of folks that I work with mostly on problems of AI model evaluation. That's generative for the most part, so language models, image generation, video generation, some other things too. My PhD was in linguistics, and my dissertation was in cognitive neuroscience of language, so that's also something that I'm very interested in, even though recently it's been much more on the ML side. Yeah, I'm excited to see all you folks and hear what you all think about AI.
All right. My name is Melchior. I'm an assistant professor here. I'm a physicist. I work in the Astrophysics department. But I also have a kind of a double affiliation with the Center for Statistics and Machine Learning. I develop machine learning or trainable systems that combine deep learning with physics principles. So you find that under physics-informed or physics-inspired machine learning. And the main idea is to embed some amount of theory that we have and that we trust in into the neural architecture, but use the expressiveness of that neural architecture to capture the aspects that we don't, that theory can't reach. Also constructing an architecture that is much more efficient in terms of data usage. When we don't have much data, we still can rely on some of the theory to hold a lot together. But yet, if we then get a lot of data, even if it isn't high quality data, but lots of it, we can draw inferences that go beyond the prevailing theory and potentially even test the prevailing theory.
Yeah, I'm Hagen Blix. I'm a non-fiction writer. I wrote a book about the political economy of AI called Why We Fear AI, together with Ingeborg Glimmer. By training, I am also a linguist and cognitive scientist. I have published both about technical aspects about AI and language and about a more political and economic perspective on AI.
Wonderful. Hello, everyone. My name is Jaime Fernández Fisac. I'm a professor here at Princeton, assistant professor in electrical and computer engineering. And my research focuses on safety for robotic and AI systems, in particular, those that need to closely interact with people. So to give you a quick sense of what that might mean, right before coming to Princeton about 5 years ago, I was working at Waymo, trying to figure out how to get autonomous vehicles to interact with people in a way that is efficient and smooth, but fundamentally safe. And so our focus and the way that I think about safety is just fundamentally something where you cannot separate your design of the AI and the robot system from the human or the humans that it needs to interact with, and safety is really not something you can just have be up to the robot. And in a consistent way, precisely because it's just impossible to build a robot that has a perfect model of the human. That's just never going to happen. I'm also a strong believer that one of the most important challenges that we need to get right in order to have technologies that work well for us is solving the fragmentation problem. Having the scientists, the engineers, the philosophers, the psychologists, the social scientists all work together to figure out how to put together the different pieces of the puzzle rather than fight about whose piece is the most important one. So I'm very much looking forward to this discussion and learning a little bit more about what all of you are thinking.
Wonderful. I'm Mel. I'm here, I think about philosophy of AI and science.
Wonderful. So we have researchers from across many disciplines. So maybe we can start by speaking about the role of AI in your current research, and maybe more generally, what you believe the role of AI should be in scientific inquiry.
Do I have to start again? I'd rather not start. I guess I can start. Yeah, so all of my research currently is focused on AI, in particular evaluating whether generative models are working to specification. It's kind of an interesting problem because it's often easier to come up with what the specification ought to have been post hoc than to come up front with what you want the model to do. And that's partially because a lot of the ML models are really good at fitting to some sort of a distribution. That's kind of what you're doing when you're training. And so then after you fit to that distribution, you're like, wow, what is this useful for? What can I actually get out of having, let's say, a really good coverage of a distribution of text corpora? So then eval is sort of in this interesting position where you can kind of look back and try to be like, oh yeah, so what was this actually a model of? I feel like it's sort of inverse to the way that we usually think of, let's say, science or even scoping out an engineering project. Usually you come with a plan. But with this current mode, one can think about it the opposite direction. So that's kind of what my team does. Most recently, we've been focusing on measuring robustness of ML models. So if you ask them the same question in multiple ways or multiple times, do they actually always come up with the same answer? This is something people want if they want an ML product. That makes sense. Does it actually happen? To what extent can we improve that? So that's like I guess my current research in it. You actually had two questions, right? How should AI affect the scientific process?
Yeah, or inform scientific inquiry in the future or more generally.
Oh yeah, that's a really hard one. I mean, I feel like I have an easier answer to say how it shouldn't than how it should.
Yeah.
I mean, I've been particularly interested and maybe with some trepidation recently about LLM technology, which I've been working on, and how that affects actually the process of science. So we have this historical way where we write papers, we ask our peers to review them, they get published. If they're good, people will cite them and pick them up later, and that's sort of like a cultural mode in which we interact. I've been increasingly helping out with editorial in various contexts in the NLP world, and it's been just very unpleasant to have kind of an onslaught of low quality and untrustworthy papers. And basically the existence of these paper generators really questions whether any paper has been written by a person, whether any paper is worth our time, and it's basically undercutting the methods that we have to evaluate what is actually new scientific knowledge. I find, which maybe you guys do too, I fall back on like, oh, this paper came out of a lab of my friend, therefore I might trust this one. And that's like, it works okay, but that only works as far as your social networks go, right? And so in a sense, it's kind of making everything into this funny social network problem. This was always sort of the case, but I feel like it's becoming more extreme. So I guess that's my kind of top of mind trepidation about how AI and science are currently interacting.
And we also know, we know that at least historically, the social network of science proper has a lot of biases built in.
Yes.
Yeah. Indeed. It seems like even though it's a lot of work for reviewers and probably very difficult to scale if the number of papers is just blowing up because it's easy to generate them with AI systems, it seems like there's no other option though than to have reviewers carefully consider the papers and evaluate them on merit and figure out whether what is actually being reported is careful, rigorous, validated science. And that's much harder than saying, oh yeah, it's a paper from these folks and it seems to be well written, but unfortunately there might be no alternative unless we get really good low quality LLM paper reviewers.
Right, there's a certain irony in having a technology that's supposed to make data more structured so that's easier for humans to go through the results, but it turns out that once it is used for generative purposes, it actually becomes much cheaper to generate signal of some kind, and it gets much harder to filter out the signal to find the right thing, right? Like the problem with the review is that the cost of producing the good review hasn't gone down at all, right? It doesn't really help very much. But the cost of producing a bad paper that looks like a good paper has gone down to close to zero, right? So the mechanisms that we had before, there are mechanisms of scaling trust, of making papers from people that you don't know accessible, right? Like concerns that economists are interested in as well, right? How do we build these networks where we can trust strangers. Right? These are kind of getting undermined, and I don't know if the mechanisms that we used to have are successful enough to counterbalance that.
In a sense, it seems like maybe the closest mechanisms, and perhaps a field we may want to look to get some reference, is cybersecurity. There's this, I think it's fair to say that right now the research community is under something analogous to what's called a DDoS attack, a distributed denial of service attack. For those of you who are not familiar with this, is a kind of very silly but sometimes highly disruptive attack where an attacker just realizes that they can send a bunch of bogus requests to a particular server and just completely collapse its traffic because it's just trying to just go through all of them and figure out, oh no, yeah, this one's bogus, oh, this one's bogus, this one's, oh wait, here's a good one. And so it's just unable to attend to the legitimate requests because it's just completely inundated. And I feel like maybe we need to, in the worst case, we may have to look for defenses. How can we build sort of DDoS-resistant peer review system in our communities?
Mm-hmm. But isn't the volume actually the real problem? I mean, I understand practically it is, but there are lots of papers that are written that are sort of meh, where you think that, yeah, okay, that didn't need to exist, but it does, and that's been true for a long time. And so in some sense, and that actually gets back to the question you asked about what is sort of, how are we using it? What I find compelling about the technology, both LLMs, but also kind of deep learning architectures for different purposes, is that they summarize incredibly well. They summarize data very well, they summarize text incredibly well, and the summarization might be insightful to us. And that's what science is in the end about. A paper that is written, is published somewhere, but doesn't actually advance anything is a drag. It's a problem, I grant you that, but it isn't, it's not the end of science because science is advanced by the papers that actually do mean something. And therefore, filtering them out, I don't think has become any harder, other than being volume. So there's a rate limit now, and so your analogy is really apt on the DDoS. It is not particularly clever, but it's a lot.
I mean, I think we also had sort of citation as a proxy for whether something was useful, and I think that is also being kind of DDoSed, to use your phrase. Which makes it harder even after something has been out for a while to know whether it's actually meaningful. Yeah. I do like this idea of summary, though. I think of it more of as maybe a compression from which we could create a summary or some sort of abstraction. Yeah. And those compressions don't always end up in a useful abstraction, but sometimes they do. And I also find that to be kind of one of the more exciting opportunities.
Yeah, exactly.
Particularly in things like unsupervised or self-supervised learning. I think those are very cool. So how much can you actually compress? How much information is actually in there? How many features do you need to describe this data? That's, the awesome stuff, for sure.
And I mean, that's the part that we're, say, maybe in physics, we have a different expectation or a different requirement for what, say, a scientific analysis needs to lead to. A colleague of mine has recently called it the search for the latent code. We actually don't care about predictions in themselves. They're useful in many cases. But beyond making a prediction of how a system behaves, I would like to know why it behaves that way. So there's sort of which then will be turned into theory eventually once this idea manifests itself as being reliable and trustworthy in other experiments. But there is the ability to predict something, which is the target of most machine learning architectures, is not actually sufficient for making a scientific breakthrough. It's at least not in physics. It's the understanding of what is being sort of described here, sort of adding to our own worldview and sort of extending the model of how the world works is what we want. It's not always there, and these sort of summaries may be useful for that. They're not always, right? But they may be useful for this.
I think the point about making this distinction between predictions and understanding is really crucial, and I think that's a lot in my mind of what Mel's talk was about as well. And one of the reasons that I think that's a really crucial question is because I think that the difference looks very, very different from the inside of science, where we treat predictions as one of the many instruments that we have to get towards understanding, and from the outside of science, right? I think if you look at the history of science in the last 200 years, you get this explosion of research funding, especially in the wake of World War II. And one of the reasons is because from the perspective of, let's say, capitalist economies or modern states, they fund research not because they think it's interesting when people understand things, not because they love wisdom or something. They fund it because they think there will be economic advantages, you will gain competitive advantages in the world market or in military applications, etc. Right? So they're interested in downstream effects of understanding. But up until this point, I think it has just been taken for granted that understanding is the best way to get the predictions. But what they care about is, in a sense, the predictions. They don't the understanding to the aims that states and multinational companies have. To them, understanding is, in a sense, overhead. And so far, that has been irrelevant to the political economy of science because there wasn't any getting good predictions without getting understanding. And I think one way of thinking about what's happening there right now, and one way of thinking about exactly the things that Mel was talking about, was like thinking about this as an attempt to pry these apart. Can we get rid of the overhead of understanding from the perspective of these forces of political economy? And I think that fits into a much wider picture of how we can think about AI, and especially generative AI, which is it's an attempt of restructuring not just where knowledge is situated in an economy, but also how knowledge is valued, right? Like I think the biggest effect of AI in the economy is not that it replaces people, but that it replaces well-paid, highly skilled jobs with a lot of jobs where people are like, you fix the output of the AI. It's about making people more replaceable, right? So I think we see this disentangling of different human values, and we're seeing that the value of profit is being imposed on a lot of these structures through AI.
Yeah, I mean, in some way, I think that we know that in a lot of ways, prediction is an important intermediary towards understanding, right? We have to understand the sort of contours of the patterns of the world before we can, we have to be able to know what the facts are in a raw way before we can get kind of insight into what underlies them. But then when we want to do the kind of end result prediction, when we want to engineer things, when we want to act on our knowledge, we need to know where that knowledge goes OOD and that it will still apply, right? We need to know what the limitations are of what we know. And again, we can't without the deeper understanding. And it's curious to me that it seems as though there's a drive to, in a sense, eliminate the need for science in favor of engineering without understanding what science or engineering are and how they relate to each other. Because if you understand what science and engineering are and how they relate to each other, you know that you can't just collapse science into engineering. That what you get is crap engineering from that. But maybe for short-term profit horizons that doesn't matter.
Right. Yeah, I do think the horizon is interesting there, right? I'm not a historian of science, but my impression is very strongly that if you look at the development of the steam engine, that in a sense you get all these tinkering engineering progress steps, and that the theory of thermodynamics actually comes afterwards, right? That in a sense, in the 19th century, you very much have engineering in the driver's seat, and science is something done kind of after the fact, versus the development of then in the early 20th century, the electrical and the chemical industries, where you kind of get an inversion, where you get much more science funding, and where there's more often downstream engineering effects from science than in the 19th century. That would be my vague impression. So I wonder to what degree that's just a given of how knowledge operates in human societies, and to what degree this is actually a very concrete question of the particular moment.
Well, it seems like it may be that there are trends by which it shifts, but it's certainly the case that I think not only historically but fundamentally science and engineering feed into each other. And you definitely see this at a place like Princeton, where sometimes the boundaries are quite blurred and it's unclear who's an applied scientist or who's a theoretically inclined engineer. But there's perhaps something deep here, an interesting connection that maybe there's an analogy between sort of in the human activity of science and engineering versus in the sort of in the way in which we build machines that use information and structure information in various ways. And it, I think, really connects to decision theory. So I guess what I'll say kind of sort of has this dual interpretation. When you're looking at the general theories of intelligent systems are essentially systems that are able to acquire information about the world through observations, and then they're able to act on that information to accomplish their goals. And it's really this sort of dual activity of you're gathering the information and then you're putting the information to use, as you were saying. And what is kind of interesting is that if you ask what is the right amount of gathering information, how good an understanding of the world do you need to have, the theory of what makes an intelligent agent will usually tell you, well, essentially to the extent that it's going to be actionable, that's going to allow you to make a better decision. But what is kind of tricky here is that it's not easy to predict. You know, we kind of get pushed back into the problem of inference, which is you can't always predict exactly how accurate your understanding needs to be in order to make good decisions. And so, you know, you can look at the aspect you were bringing up earlier about geocentric theories of the universe. Well, those were pretty okay for as long as we were just, you know, mostly interested in activities that happened exclusively on planet Earth and didn't necessarily require us to have, you know, satellite systems for communications or space travel or anything along those lines. But at some point, the model is not good enough, and then you need a better model. And there's a way in which you could say that if you're doing engineering, then in a sense what you're doing is you're overfitting your science to the problem that you have right now. But on the other hand, if you're just doing, you know, forever doing science and just looking for a better and better model, and you're not particularly focused on, wait, at what point is this a good enough model to act on, then you're also losing out on that. So it seems like what you need is a good balance so that you're not getting blindsided by situations where your current understanding is not applicable anymore, but you're still getting good value out of the information that you do have. And I think this is true both of human activity and the way in which we should build these systems to be helpful to us and not get in trouble.
It's interesting. I think in the history of science too, in the history of statistical mechanics and thermodynamics, we had a mechanistic account of what was undergirding the behavior that we were seeing of, you know, thermodynamically enclosed systems at certain pressures and volumes and such and such and such. It was just, we now think of it as like a really confused mechanistic understanding about what was going on that was later replaced by what we now think of as, I mean, and nowadays even we have kind of competing explanations that we understand to work at just different levels, but the ones that we had then are no longer in play.
Yeah, I was thinking when you were talking, Mel, about kind of theory-less or theory-free direction that AI seems to be going towards in this context of Kuhn. So the Kuhnian scientific revolution that has sort of the stages you two were describing of like, there's like normal science. We all believe some sort of overarching principles, have some concepts in science, and we like work together. and push the boundary just a little bit. You might think of it as these big balls. I don't know if everyone trained you guys had these. They would draw a big circle and they'd be like, your dissertation's going to be this. And they make a tiny little bump, and it's going to increase the human knowledge in just a tiny little direction, and that's like what your goal should be when you write your dissertation. And that's kind of this notion of, yeah, normal science. But then there's these moments that are paradigm shifts, like the geo to heliocentric model, maybe this thermodynamic stuff, and then somehow that we have a completely new worldview after these shifts. And people have been asking me or talking to me about whether AI is one of these. And I found I was like just really uncomfortable with this framing. And I was like, why am I uncomfortable with this framing? Like, in a sense, yeah, we're like thinking about things differently. And as you said too, maybe the like in the presentation, maybe the lines of disciplines are going to change. I think that's true. We now have departments that are like AI-centric, or data science is merging into AI, whatever, all these different things. So it's like, maybe. But I realized what I was uncomfortable about was this notion of like scientific revolution. Because to me, the theory part seems to be maybe the most important thing. And sure, we had one theory, geocentric, that got replaced by another theory, heliocentric, but there was always maybe a theory. And at this point, we're aiming for not a theory anymore. No theory at all, right? At least in the stories that the AI people tell themselves, whether that's true or not. So maybe it's not exactly a scientific revolution. Maybe it's something like a meta-revolution, an anti-science revolution, that maybe we have something else that's not science, that's going to replace this and reorient everything. But it feels crucially different. And I don't feel comfortable thinking of it as science, the thing that AI is trying to push towards. But yeah, I'm curious what you guys think about that. Have you been hearing these same kind of hopeful discussions of AI scientific revolution, or, yeah?
Quickly, should we introduce, I mean, for those unfamiliar, the concept of, I think this is the most widely read philosophy of science book outside of philosophy of science, but Kuhn has this idea of science operating in kind of stages. So within each discipline or sub-discipline, you have stages where you're first pre-paradigmatic and you don't yet know, you don't have a strong sense of what you're studying. And then you have a kind of period of normal science, and then science goes through revolutions or paradigm shifts where we have a kind of, like, you hit a saddle point and we go from thinking it's this way to thinking it's some other way. And there's maybe there's a naive co-option of the idea of Kuhnian paradigms in discussions surrounding AI, where there's this idea that we're going through a paradigm shift, but maybe in some ways we are. I don't know.
Things are changing.
Things are certainly changing rapidly and aggressively.
Well, speaking of changing, in the interest of time, we do have 10 minutes left, and then we'll do a short 5-minute Q&A from the audience. But let's transition from science to society. As researchers, as scientists, what are you most concerned about with respect to AI's increasingly prevalent role in society?
I'm worried that we're deploying this technology at an unprecedented rate, at which we have not deployed any other technology in, I don't think recent memory, but like in all of human history. And we are very far from having good understanding among the scientists and engineers who are building these technologies, let alone folk theories of it. And this makes it extremely difficult, number one, to make sure that we're building the systems in a way that is beneficial and safe to people individually and collectively and institutionally. And it's making it very difficult for people to understand what is happening and what they are allowed to ask for. And this final part worries me a lot. So, you're seeing a lot of discussions between policymakers and technologists where the technologists are essentially deflecting the questions and doing some kind of hand magic, and suddenly everything's fine, and I guess they're already doing things the right way, and we're not exactly sure what it is that we would like them to be doing that is not what they're already doing. And that's essentially because perhaps we are pre-paradigmatic, at least as a society, in this way, and we don't fully understand what these systems should be built to do and to guarantee to their users. And I think it's unlikely that this is going to happen by itself without a huge effort from across communities in in science, in academia, in industry, in public policy, civil society, and international cooperation. And it needs to happen quickly, or otherwise this is just going to happen in whichever way it falls, which might not end up being the way that we would like.
I would say autonomy is the one thing that makes this very scary. So when you think of like autonomous agents making decisions that, as Mel you said earlier, they have aspects in healthcare, they have in the military for kind of autonomous weapons, in kind of law enforcement and kind of sentencing decisions, and in all of these places where decisions are made on the basis of things that are marketed as objective, and then do something that has serious implications for the life of people. That's the part where I think one needs to be incredibly cautious and careful, even if there are some aspects where the time savings that are inherent to such a technology might actually be valued within that discipline. So you can hear that from, say, the medical disciplines, that they are overworked and they would like help in what they need to do. But that is it is a very kind of short gap from doing this to effectively getting humans completely out of the loop on something that will in fact have significant implications for how people can live their lives or how they're being ended by technology.
Perhaps I'll slightly push back on this with a quick thought, which is that actually autonomy might not be the main thing to worry about, in that it's actually the interaction between these systems and human users and institutions in society that can lead to the sort of largest and fastest growing impacts. And that part we don't understand well enough. And to give a quick example, with autonomous driving, often the big challenge is how do you get the system to drive correctly in the midst of, regular traffic with pedestrians and cyclists and drivers who are all going about their business, who are not going to play by the official rules of how you're supposed to use the road. And if everyone, if every road user was an autonomous car, that problem would actually be significantly easier to solve. It's in the subtleties of the interaction that we can actually end up with systems that are unsafe, because we designed them assuming that humans were in a certain way, and as you were bringing up earlier, sort of mistaking our model of reality or our model of people for actual people. And we're actually already seeing this happen in multiple ways. One of the biggest problems that we're seeing in current language model-based systems is that they are extremely sycophantic and that they significantly err on the side of giving us good news in general and saying things that sound correct and accurate and rigorous rather than actually giving us useful information. But the reason that they're doing this is essentially that we are training them based on human feedback. And guess what happens when the feedback comes from people who are, regular, real human beings who can be, slightly tricked in subtle ways by the tone in which something is said or by something that is phrased in a very convincing way, even if it's not quite true. Well, the system actually learns from that to do more of what gets it the thumbs up, which happens to be, essentially, to get increasingly good at exploiting
Right, and in
people.
our LHF, we're trying to get people to nudge the system into better behavior, but we're nudging them into nudging it in a certain direction. Right, we ourselves are subtly manipulating their behavior into manipulating the system's behavior in a certain way.
That's right, and the system learns to manipulate them back, right? That's the tricky thing. Again, it's not that the system is autonomous and operating in a vacuum, it's that the system is learning and it's adapting to however it is that people are behaving. So it is a mutual adaptation process, which makes the problem much harder and in a lot of ways much more interesting, but it's much more dangerous if you don't get it right.
Yeah, I want to maybe introduce the concept just briefly of techno-solutionism, because what you speak of with hospitals, I mean, it's not necessarily the case that I as a surgeon have to work a 40-hour shift to the point that I'm blacking out. You know, this is how we've designed institutions, and the idea of techno-solutionism is that there's some deeply ingrained systematic, structural, or institutional problem that requires institutional reforms, but we just throw the latest technology on it to kind of mitigate the symptoms without addressing the institutional underlying issue.
To me, the biggest concern, especially with generative AI, is I think the simultaneity of two social processes. I think there's on the one hand the process that I already mentioned of, I think it's a wage depression device. It's some of it are productivity increases, and productivity increases are great. That means we as societies can produce more and consume more. But some of it are just wage depression, and wage depression just means of all the value that's produced in society, more goes to capital and less goes to labor. And clearly what we're seeing is something that you can call the logic of industrialization is coming to intellectual activities, to text production, right? It's the industrial production of language, and we know from history how industrialization processes play out for the people who work in certain domains. It's a few people win and many people lose, right? So we're seeing an undermining of an already destabilized middle class, and simultaneously we see that these devices can be used to really undermine, you know, a sense of reality. And I think the problem is not just that people don't have a shared reality anymore. I think the problem is that there's a deep aspect of fascism, where fascism is always not fascist propaganda is not about convincing you of what they want to believe. Fascist propaganda is about making it into a ludicrous thing to believe anything at all, right? I think Sartre has a fantastic book on anti-Semitism, anti-Semitism has nothing to do with Jewish people. It has everything to do with like a kind of sadistic, playful way of being able to say whatever you want without ever taking any kind of accountability for it. And I think this conjunction of a destabilizing economic situation plus a climate in which we already have strengthening fascist forces everywhere in the West, and now you see this technology that has all these affordances for automating the destruction of a sense of anything is believable, right? Like I see anything on the internet now that is kind of surprising, and I'm like, this must be fake, right? It's like that. So, and that's the cynicism that is creeping into me, right? Like I feel the cynicism about anything that might be believable or interesting or whatever on the internet coming onto me, and I think it's that like kind of cynicism, that nihilistic approach towards the attempt of can we believe anything about the world? Can we produce a shared human agenda for making the world into a better place? Anything like that. It's that undermining of that positive sense of can we organize ourselves as human beings to go for collective goals of how we want to shape the world, and replacing it with that nihilism and cynicism and this like playful cruelty. When these two forms come together, that is, I think, what scares me most about AI. That these two destabilizing forces.
It's also kind of like a blitzkrieg on our information ecology, right?
Mm-hmm.
And that's
It's like a DDoS attack on our information
It's like
ecology.
a DDoS attack on our information ecology.
But even in the sciences, that has like significant consequences, right? Because the very thing that you just said, namely that you see something surprising on the internet and you immediately distrust it, that's actually the stuff that normally drives scientific innovation.
Yes.
It's the stuff you don't expect. It's the stuff that you that doesn't conform to your worldview, right?
Yes.
And so it cannot possibly be right and explained within the model you have of the world. and therefore it requires investigation or deserves investigation.
Yes.
And this can go away, right, if we start distrusting everything that looks surprising or odd.
This is why I'm really concerned with injecting LLMs into a kind of cornerstone position in how we produce science, either in peer review in a kind of meta-epistemic role, or in how we generate papers, how we AI agents for science where we're generating experiments. That it's not a paradigm shift. It's locking us permanently and forever in one paradigm, because anything that falls outside the norm is no longer believable, is no longer predicted, it's like anything OOD is no longer.
There's a name for this in machine learning, which is mode collapse. And what happens when you have some model and you feed it its own data back onto
And we
itself,
want that for science, right?
is it loses, oh yeah, that's great, right? How to never learn anything new. You just keep telling yourself that you're right until you absolutely discard anything other than, the mode of your distribution. It's it's sad, but it's a tendency, right? And I think it serves to be aware that these dynamics exist. Again, in human activity as much as they do in the training of machine models, machine learning models. But we really should ask who's benefiting, and in whose agenda is this part of when we are getting into we're drifting towards a situation where there's increasingly widespread skepticism and cynicism and nihilism across society. Someone must be benefiting from this. It's probably not science or the average citizen, but
the other
someone's getting rich.
The other worry I have that's kind of alongside this kind of maybe fascistic tendency to create confusion and disbelief is just the increasing kind of penetration to our lives of surveillance everywhere, all the time. And I think it's a similar question, who's benefiting from collecting every minute of our day, right? And that means like both video of you, any text you have online, any wearables you're using, all of that data. I think some people call it the Umwelt, the environment that you're in. All of that enables predictions to be made about you and control to be had over you in a lot of sense. And not just from suggesting which ads you want or whatever, which, some may argue is actually social good. It doesn't waste your time or something. I mean, we can disagree with that. But it will be increasingly difficult, at least as far as I can foresee, to have kind of a private time in the world with yourself, with anyone else. That also kind of worries me, that kind of collapse between lack of privacy and control over you. The fact that those seem to be coming ever closer together.
I mean, perhaps one of the most harmful and, by definition, dehumanizing forms of statistical models gone wrong is the use of behavior prediction models for people, where you're trying to do something like, we want to maximize user engagement. And what you end up doing, whether explicitly or implicitly, is you're building a model that enables the system to figure out what it needs to do to maximize the probability of a person clicking on the next article or remaining engaged watching whatever content you're presenting to them. And because we're not at all interested in understanding what's going on internally, we're not really sensitive to the fact that people are actually not happier or in any meaningful way benefiting from all of the engaging content that they're consuming.
I mean, this is kind of cybernetics 101. It's like good prediction over a fundamentally unpredictable system is good control over that system.
That's right.
Right, you can't predict a complex system. Human behavior is a complex system.
Yeah.
Good
Instead, you
prediction
can
over it is
control
good
it.
control.
I'm trying to think of a segue from controlling to Q&A with the audience, but it's not coming to me. But thank you so much to our wonderful panel. We're now going to take questions from the audience. We have about 5 minutes.
Passing control over to the audience.
Indeed.
Well done.
We're democratizing control.
Yes. Oh, sorry, I was calling on you.
I guess a couple minutes ago someone said, I forgot, I think it was you, that basically part of the issue with, just take scientific papers as an example, but what I'm going to talk about kind of applies to everything. And part of the issue with the scientific, AI-generated papers not becoming a thing is not that these models just allow people to make papers equally quickly. It's that they allow you to make a bad paper look much better, right? The problem is that not all slop is created equal, right? And so now it's kind of like if you imagine, like, I'm not an expert at all, or not, I don't know anything about the history of currency, but like, I think there is an effect where like currency got more and more complicated, whether metal currency, paper currency, as the means to counterfeit it got more sophisticated, right? You have to have watermarked bills by the 1980s or whatever, because printers were good enough that someone could print a $50 bill or something, or print 100 of them. There's an issue with scientific papers where it used to be, if you're doing a review, it was pretty easy to tell which papers were really bad, right? The amount of effort that you would need to put in to figure out if a paper had some like serious error was probably lower. The same paper you could today use, certain LLM technologies to make the language better, maybe to, make the argument seem a little more plausible. I've noticed this with programming, where like the kinds of bugs that an LLM sticks in code, because these things are trained on the natural statistics of programming languages and human programming, the kind of bugs that end up in the code are very hard to find. And not the kind of bugs where
It's not obviously wrong anymore.
Yeah, if I was reviewing one of my friends, the kind of mistakes people make are somewhat easy to detect. And I think the same thing's true with papers. So what you've done is you haven't just increased the number of kind of slop papers, you've also made the amount of effort that a reviewer needs to put in order to determine that a paper is bad much higher.
Yes and no, right? So the question is the reviewer also AI enabled, which increasingly they are. So we are basically closing the cycle. But you can ask the question, given this paper, whoever produced this, right? Are there like fundamental? So are there inaccuracy in there? You can ask an LLM to kind of to sort of review and fact check the paper. You will have to fact check what it fact checks, but there are ways to kind of streamline this. And the other one is there any statement that make this sort of very distinctive? Is there any sort of really fundamentally new insight? And I mean, it's an insight that an LLM would recognize, but they're really good at like overall summarization, as we said earlier. So the question is, are reviewers using LLMs in a way that at least somewhat mitigates the onslaught and the increase of quality? You're perfectly right. There is absolutely an increase of quality, and now something can look absolutely beautiful and be nonsense nonetheless.
I would argue that what you're identifying is, in fact, as you were saying, not just a matter of research papers or code. It is something fundamental and something structural that is there, that has to do with the fact that you can break any kind of evaluation system if you are able to target the proxy that it is using for measuring quality, right? And so how are we getting bad papers that look increasingly good? Well, it's because these are essentially being trained. And by the way, this was happening with humans too before we were using language models to create these massive onslaughts of papers, right? So this is the thing that you kind of see happen. You get a gradual shift towards people also figuring out, what is the gestalt of a good paper? How do you get a paper to look good? And when you're sort of submitting a paper to a community that is not the one where you typically publish, you kind of have to learn, what is the way, how do I speak their language? How do I present the paper in a way that the reviewers of this conference are going to like? There's some extent to which that's not a bad thing. You want to communicate in a language that will be understood and will resonate with your audience. But like everything, reinforcement learning from human feedback, it's good at the start to some degree. It's good that the language models learn to not just copy anything they see on the internet. As Aristotle said, never trust anything you read online. But on the other hand, you can do too much of that, right? And you can get to a point where you're just optimizing for the immediate approval. And then you get bugs that are way harder to find because the system is not getting good at not having bugs, it's just getting good at not getting caught. with bugs.
Like, how do you have trust? Because I'm more concerned with the question of this, like the social. If you think of science as like a social institution where people are trying to discover things and be in conversation with each other, and Republic of Letters and all that, like, how do you build trust in a social system when the cost of making counterfeits or the cost of making, I don't even want to say slop, like good fakes, drops very close to zero? Because like if you think about news or a lot of that stuff, like, yes, people made fake websites. That was the thing 10 years ago, the original use of the term fake news, right? You'd make like a fake newspaper website and you'd put up some story and you'd write it, and you could write it in newspaper English. People know how to do that, but now with pictures or videos, I think there's a similar question in science, like when the cost of making something that's, isn't what it claims to be, right, on some level, whether it's a just mediocre paper masquerading as a groundbreaking one, or like, I guess, and the answer might be that, no, we have new tools to actually sort through, so the cost of detecting a counterfeit is also lower, right? I mean, I think, but I guess that's a question, is does that work both ways? I've always kind of, when people ask me like, well, how do I catch deepfakes? It's like, well, you can, train an adversarial, like you can train a, vision model to actually detect deepfakes somewhat well. Like maybe it's just there's always going to be some sort of balance where the difference, because it isn't just about the, how easy it is to make a fake. It's about how easy it is to detect one compared to how easy it is to make one. And trust is some function of the difference.
So I think this actually ties to the ages-long, I think, philosophical debate of, does truth always win out? Because once you present somebody with the truth, they've seen it, it's just hard to convince them otherwise, like the lies fall apart. Unfortunately, this is, at least empirically, not always the case, right? Because people are imperfect judges, and machine learning systems are also imperfect judges. This is something that was discovered, quite a few years ago in sort of the previous generation of generative AI with something called generative adversarial networks, where you could train pretty good imitations of lifelike photos by just having one machine learning model be in charge of discriminating between a real photo and a fake photo, and just like continually train the generator to trick the discriminator into deciding that a fake photo was a real photo. And you can actually get really good at that. And there's this kind of debate in the AI community about whether now in a loose way, the Nash equilibrium that you will reach in debates between two language models talking to each other with a human judge, whether the debate and exposing flaws in each other's arguments will ultimately lead to the human judge always being able to tell which of these models are telling the truth, and therefore these models will just be trained in this way to always tell the truth, or whether what will happen, much like in politics, is that whoever makes the strongest case by pressing the right button and turning the right knobs is going to win, and so these models are actually going to learn to be extremely good bullshitters in the philosophical Harry Frankfurt sense.
On that note,
feel very hopeful about
on that note, we are at time. Let's thank our wonderful panelists for coming today.